Hello, this is Mrs. Decker, and this video will cover objectives 2A, 2B, and 2C. 2A and 2B are on equilibrium and explaining what that is in terms of the rates of the forward and the reverse reactions, and also being able to identify when a chemical system is at equilibrium. And then 2C gets into Le Chatelier's principle and predicting when a system is at equilibrium, if it will shift left, right, or not at all when stress is added to the system. So let's start by talking about what equilibrium is. In order to have a chemical reaction that is at equilibrium, we need to have a reversible reaction. So it's a reaction that not only happens in the forward direction, it also happens in the reverse direction at the same time. So we have the reaction happening in the forward and the reverse reaction at the same time. And you can see a reverse reaction by having this double arrow. So when you see the double arrow, that tells you that the reaction is reversible. So chemical equilibrium is reached when the rate of the forward reaction is the same as the rate of the reverse reaction. It is important to note, that is why this is in all capital letters. This does not mean the amount of reactants and products is the same. It means that the rate of the reactions is the same, but there could be different amounts of reactants and products. Okay, so in 2B, you have to be able to tell when a chemical reaction has reached equilibrium. So to do that, we use the concentrations of the reactants and products, not the amounts, the concentrations. Okay, so when the concentrations of the reactants and the products remain constant, it means that the forward rate is equal to the backwards rate of the reaction. So they might have different concentrations, but they are no longer changing. That is when equilibrium is reached. Okay, so here we have the forward reaction starts off fast and then starts to slow down. And then the backward reaction doesn't start until we have some buildup of products, so then it will speed up until it reaches an equilibrium state. So once the two lines, the rate of the reaction, have become equal to each other, that's when we're at equilibrium. There is a YouTube video called What is Chemical Equilibrium that I would like you to watch. It gives you a visual for what equilibrium is and how you recognize it. All right, so now we're going to get into objective 2C and Le Chatelier's principle. So the principle states that if stress is added to a system at dynamic equilibrium, the system responds in such a way to relieve the stress. So dynamic equilibrium is important. Dynamic means that the reaction is still happening in both directions. We just don't see any changes happening in the reaction. So it's not a static system. Things are moving, things are going on inside at the molecular level, but we can't see that at the macroscopic level because it's in equilibrium. Right? So there are three factors that can cause a system to shift when it is in equilibrium. Those are adding or removing reactants or products, adding or removing heat, and increasing or decreasing the pressure. Adding a catalyst is not going to cause a system in equilibrium to shift. It will just help the system reach equilibrium faster by lowering the activation energy for the reactions. Right, so the first stress we're going to talk about is adding or removing reactants or products. So here is our reaction here. In the equation, if the system is at equilibrium, adding more of any reactant or product will cause the system to shift away from whatever is added. Removal of a reactant or product causes a shift towards the removal. So what I want you to do is write in big letters, add equals away, and remove equals towards. So this will help you remember which way things are going to shift. Anytime you add something, it will shift away from what is added. Anytime you remove something, equilibrium will shift towards what is being removed. Okay? So if we look If SO2 or O2 are added, equilibrium is going to shift to the right. You're adding, so equilibrium shifts away. Okay? And then if we look at the product, if SO3 is removed, if we're taking that out, it's going to shift towards it, so it will also shift to the right. Okay? So either adding reactants or removing products for this reaction will cause the reaction to shift to the right. Now, if we look at the other side of that, if SO3 is added, the reaction is going to shift to the left. And then if SO2 or O2 are removed, the reaction is also going to shift to the left. So in this case, adding products or removing reactants is going to shift the reaction to the left to make up for that stress. Okay, so next we're going to talk about the addition or removal of heat. This is an exothermic reaction because we have heat written as a product. And if you remember from Unit 6, when heat is given off, it is written as a product, and that is an exothermic reaction. So we want to write heat or energy. It could be heat, it could be plus energy, it could be plus 56 kilojoules. Anytime you see something like that, you're going to write it in the reaction, and you'll treat it like you treat adding reactants or products. If you add heat, it will shift away from where the heat is at. If you remove heat, if you lower the temperature, it will shift towards where the heat is at. Okay, so for this reaction, if we add heat, it's going to cause a shift to the left. Okay. On the other side of that, if we remove heat, it would cause a shift to the right. Okay? So remember, heat can be written as a reactant or a product based on whether the reaction is endothermic or exothermic. This is an exothermic reaction. If you're dealing with an endothermic reaction, it would be the opposite. Okay, so next we're going to talk about increasing and decreasing pressure. So increasing the pressure of a system causes an equilibrium shift away from the side with the most moles of gas. It's important that you're looking at gas only. Decreasing the pressure causes a shift towards the side with the most moles of gas. So you want to look at the moles of gas on each side. So on the left side, the reactant side, we have 3 moles of gas. On the product side, we have 2 moles of gas. So the side that has more moles of gas, you want to write plus pressure. So now, if we are adding pressure, it will shift away from pressure. If we are removing pressure, it will shift towards where the pressure is at. So, since we have pressure on the left side, on the reactant side, if we add pressure, it's going to shift the reaction to the right. If we decrease pressure, it will shift the reaction to the left for this equation. Okay, so again, make sure you look at all of the reactants and products and add up the moles of gas only. Whichever side of the equation has more moles of gas, write plus pressure, and that will help you decide which way to shift equilibrium. Okay, so now let's go through this example problem. So it says that the following process is endothermic. That means it needs heat to get the reaction going. So you're going to write plus heat on the reactant side. So we're going to look at each of these following stresses and decide which way that the reaction is going to shift. So the addition of H2O is on the reactant side. Remember, if we add something, it's going to, equilibrium will move away from where that's added. So since H2O is on the left side, adding more H2O will shift equilibrium to the right. The next one says a decrease in pressure. So we have to first figure out which side of the reaction has more moles of gas. On the left side, we only have liquid. On the right side, we have 3 moles of gas. So go ahead and write plus pressure on the right side. So if we decrease the pressure, the reaction will shift towards where the pressure is written. So this will shift to the right. If we increase temperature, heat is written on the left side, so that will shift the reaction to the right as well. The removal of O2 is on the right side, so remember remove equals towards, so if you remove O2, the reaction will shift to the right as well. And then the addition of a catalyst will not have any effect on equilibrium. So in your packet, there's some practice for you to go ahead and work on. Let me know if you need help.